Hi, my name is Sachin, Prabhu, and this is Avan, Thakkar, and we both work at IBM in the Ceph team. So, the introduction, the team. So we are the Ceph team within IBM. We work on the SMB service, that is to export the CephFS volume using the SMB protocol. We have our own GitHub account where we have some standalone projects, including the test framework, which Anup was talking about earlier. So what is the Ceph SMB service? It provides an SMB manager module, which allows you to orchestrate an SMB service to export the CephFS volume created on Ceph. To do that, we use the container, which runs Samba. This container is built using the Samba container project, which is also available on GitHub. As mentioned, exports the CephFS volume, and we use the new VFS Ceph new module to export the CephFS volume. Oh, yeah. So before we explain what the problem was, we need to understand the forking module on Samba. So this talk builds up on what Anup was talking about, but this talks about one particular problem we faced while exporting CephFS. And this problem was also similar to another issue we saw with LusterFS. So this problem seems to be very common with clustered file systems exported with Samba. So before we talk about the problem, we need to understand what causes it. And we need to understand the forking model. So the forking model in Samba, wherein every new client connection coming into Samba, we fork a new process, where the UID and GID is switched to the UID, GID of the user who's authenticated on that particular connection. Why was this done this way? There are many reasons. Some of them are portability. It's just easier writing code which runs on a lot of platforms by using this forking model. Also, we do not have to do as many UID, GID switches when using the forking model. And also robustness, in the sense, if we hit a bug which causes one of the client connections to crash, the process crash affects only that particular client connection, doesn't affect the entire Samba server. So for that, the forking model was very beneficial, and we decided to use that for Samba. But that causes other problems. Now, imagine where we have an instance where we have a large number of incoming client connections. What happens is each client connection results in an entire new process being forked. Once it's forked, it connects to the backend Ceph server using the libcephfs connection. And each connection then has its own metadata and data cache. And these are essentially unconnected to each other, so we can end up caching the same stuff over and over again. And what happens is, under some workloads, we can end up depleting the server resources, causing performance degradation or even crashes. Yeah.
Thanks. Just to complement what you were saying, a little bit of a fine point here. So the initial connection we were talking about is a GCP connection, which triggers the fork. And the loading of the connection to the backend file system is done when the tree connect operation is done from SMB.
Yeah.
So tree connect causes the VFS module to be loaded, and this causes the whole client stack to be loaded for Ceph in this case. So the initial connection that causes the fork is TCP connect. Yeah. After that, authentication is happening, which causes the ID switch, what you mentioned. And lastly is the tree connection, so the connection to the share. Yes. Within the session. And this is the problematic one for us.
Yeah.
Okay, I didn't want to hijack the talk, just mentioning a fine point that is of importance here.
Okay, yeah, thank you. So yeah, as Michael mentioned, we have tree connects being done, which connects to the backend. Each libcephfs, each new connection has its own libcephfs stack, which has its own data cache, which has its own metadata cache. The main problem we noticed was the data cache, which a large number of connections doing I/O causes depletion of server resources, which causes the machine to crash. So to test this, we created a new loading test. This is available under SIT test cases repository. This is, again, part of the SIT testing framework, the Samba integrated testing framework, which Anup was talking about. What we do is we use a Python script to simulate a load on the machine. On the Samba server, we use the SMB protocol Python module. And what we do is we just create multiple threads with with each thread having a client connection, creating a new client connection with the Samba server. We then simulate an I/O, a simple I/O, which just opens, writes to a file, reads from a file. And each file created is about 16 meg file size. I think there are 10 files created for each thread we create. And what we noticed is this is with a 3-node Ceph cluster, a fairly beefy Ceph cluster. So that's not the problem. Then we have a 4th node, which is running Samba. This is, again, it has a 32 gigs of memory on it. When we open 100 simultaneous connections, we almost run out of memory. When we open, not just open connections, we need to perform I/O. When we perform I/O on these connections, we end up killing the Samba server because of resource depletion on that machine. Sorry. In this case, the libcephfs, it does try to manage the cache, but this cache is all separate, so the effort to reduce the cache size, because we're running out of resources on the server, it's uncoordinated and therefore very slow. It's not very effective at managing the cache size. So this is the proposed solution. This is essentially a proxy server, which funnels all the requests coming to the to the backend Ceph through the libcephfs daemon. Now, this has already been committed upstream into the Ceph repository. A design document is available on the Ceph repo itself. The main aim is to avoid having an independent cache for each client connection. So we've run the same test from the SIT test cases, the loading test, with this particular solution in place, and we were able to have more than 1,000 simultaneous connections doing the same simple I/O operation. Now, the solution itself consists of 2 parts. We have the libcephfs daemon process, and then we have a libcephfs proxy process. This is a library which takes place, which in turn is used in place of the libcephfs library to connect to the Ceph backend. So the libcephfs daemon, it uses the actual libcephfs library to connect to the backend Ceph volume. So that's where we do the actual connection. And it listens on a Unix socket. And any requests coming in, it then forwards to the Ceph backend.
So is CephFSD or CephFS proxy?
This is CephFSD. It's named CephFSD. Yeah. And the second part is the libcephfs proxy library file. So this library file, it provides a small subset of the low-level API calls which Anup was talking about. It's used in place of libcephfs.so. And there is no caching done in this case in this part of the client. It just forwards the requests from to the libcephfs daemon over the Unix socket. So each user connection, each unique user connection is then multiplexed on the proxy. And there are some cases which require special handling. For example, you could have the same users mount different subdirectories within the volume. So to handle that, we need to do some special handling for the get CW, get current working directory, or change directory calls. Yeah?
Quick remark, when I'm done with this add conversion, get change D is going to go. So we
Okay.
won't have change D anymore.
Yeah, okay. So the only change required on the configuration side is the new variable, which we pass to the Ceph new module, which just says proxy enabled yes. So to get this the proxy solution running, On the Samba server, we need the libcephfs proxy library installed. We need the daemon installed, modify smb.conf to enable the proxy server. We then start the libcephfsd daemon, and we start SMBD. So all new connections coming in which connect to the backend CephFS system is now multiplexed through the proxy. Now, we use the same spec storage tests from the previous presentation by Anup. So this one was tested against these machines. They have CTDB enabled. They are running those tests on a Ceph kernel mount. This is an older version of Ceph and Samba, because we've had some new features and in the later versions, but we wanted to test it before that. We just wanted the proxy tested. So a software build is a simple simulation of a software build. It creates about 5,000 files, so very metadata heavy load, lots of small files. And we notice higher latency with the proxy. That is as expected. So that's the software build workload. And the second workload is video data acquisition, where we read from a stream, such as a camera, and write to a single file. So in both cases, the latency was higher, and overall throughput also decreased. So in future, to change this, we have planned a few things. To improve performance, we planned a few changes. One is the metadata data cache on the client end. Now, a workload like Samba has a lot of statics calls being made. And so we think that having a metadata cache on the client end will actually benefit us. So we're trying to add this metadata cache back to the client end, this time on the proxy library. And we've also considered other options of connections between the proxy module, the proxy library, and the proxy daemon. So recently we tested with a shared memory system, but we found that the performance improvements were quite marginal. So at the moment, we're not following that. There are some other plans. One of them is like IO U-ring, to try using IO U-ring to improve the connection, but that's still something we have planned for the future. And the low-level API calls, at the moment, the libcephfs proxy library just implements those low-level API calls which are required by the VFS Ceph new module. We then need to extend this. So once we extend this, we can possibly use it with other applications which want to similarly connect to the backend Ceph through a proxy. And finally, right now, the handling of any libcephfsd, this is the daemon process, crashes. It's not really done properly. We are working on improving this so that any client reconnections is done transparently. So any reconnection is done transparently to the client. Yeah, and now Avan will be talking about further the improvements we've been working on.
Yep. So I think so far we did see about how the proxy works, and we did see there is a trade-off between like making the scaling it against the performance. But yeah, we do need to improve performance a bit for the proxy. So yeah, there has already been some work added on the VFS Ceph new module and with the CephFS async IO support. And also in the proxy, we have been adding some async callbacks, basically to improve the communication between the proxy daemon and the proxy library. And yeah, the recent case sensitivity feature, which has been already talked about. So that will, we are impression that, yeah, that improves the performance as well for the proxy. And yeah, these are the recent numbers, I would say like quite a week, under a week or so, which we got for the same the software build. So the first one you see, I think that's proxy enabled, but it doesn't, I think that's, the first one is, yeah, the proxy disabled. The next is the, yeah, proxy enabled. And the last which you see is proxy enabled plus the case sensitivity and the async IO. So yeah, we have some reduced latency, not much, but yeah, and with the VDA, I think we almost see the similar to what we see without the proxy. So yeah, that's a bit improvement there. And yeah, the throughput as well has been improved a bit for the software builds and the VDA. Like if you see for 917, that's with the case sensitivity disable and the async out disable as well versus 1072 something kilobytes per second. And the same with the VDA, it's now 23,065 something versus. So yeah, we are still in contact with QE to keep testing, get new numbers, see how we can improve that testing and accordingly plan the changes on our end. But yeah, today one of the important features we are looking for in the proxy is to add the metadata caching, like we already talked, like all the static calls and which Samba server makes. So right now, to overall, this is just, okay, what I'm talking about, why we need metadata caching, how it can be done, the challenges we have for the current approaches, and what we can do further in the future. So can you go to the next slide, please? Yeah, so right now there is a overhead, like in order to, let's say for any statics lookup or get attribute metadata operations, you need to have an extra hop, like the proxy goes to the daemon and then daemon will further call in the actual libcephfs library, which will go further to the MDS. But what if we have a cache itself in the proxy? In that case, we don't have to do the extra hop to the proxy daemon. And yeah, that will reduce, of course, those frequent statics and lookup calls, which will help us improve the performance. So next slide. And yeah, this is the overall how this works. Okay, like a given Samba client makes a metadata request, goes to the proxy. If there is no cache entry yet for that metadata, okay, we'll simply go the actual way, which is the libcephfs through the proxy. It returns the metadata. It will return to the proxy again, and it will store the cache. The cache will get updated. And in case if there is a cache entry, okay, we can just simply say that, okay, cache it, return the cache metadata. We don't need to go for the extra hop in this case. But well, that's not all. It looks quite simple, but what in case clients does modification to the metadata? In that case, well, once we modify the metadata, we need to make sure that whatever cache was stored needs to invalidate, not just for that, but for all the clients, the proxy clients, and the other clients which were using the same cached metadata. So in that case, like CephFS already does have this cache invalidation mechanism. It's kind of an async way. So how that works is basically in case if any of the cache metadata, okay, sorry, my bad. In that case, how it works is like in order to invalidate, a client needs to send basically invalidation request to the MDS, and then MDS will make sure that it basically keeps track of the rest of the clients as well, which have this cached, basically the clients who have cached this metadata, so it will notify all. And once this is all asynchronous, so it doesn't wait for the ACK from all the clients. So once that ACK is received, I think, and the rest of the clients will trim their cache basically. And this is what the similar model we are planning to use for the proxy as well, that once the proxy daemon basically, what it will do in order to actually implement this, libcephfs does provide some callbacks, the invalidation callbacks, like inode invalidation, reentry invalidation callbacks, which libcephfs, the proxy daemon, could register. So whenever MDS does trigger that invalidation notification, the proxy daemon will know of that, and in the proxy daemon, all we need to do is implement a way to notify all the proxy clients about this invalidation, and once the proxy clients will get that notification, they need to trim the cache. But well, this is not a perfect model, I would say. The next slide, please. Because since it's asynchronous in nature, so once you modify and then invalidate, what if there is another client, it wants to request the metadata, and the invalidation has still not happened for all the clients. So you have a stale data which the client B will be reading in this case. So, and well, that's not something we want for the user to read a still metadata. And for that, next slide, please. So these are the solutions we have been discussing so far with CephFS team. It's still underway. We haven't yet made on much progress. There's some proposals we have. One is like, what if we just simply make all it synchronous, just to wait for all the clients to send back ACK to the MDS, and once that is done, then we will further process those requests, the incoming requests. But till then, what we are doing in this case, like in case with thousands of clients, well, we are asking them to wait to finish the ACK from all the clients, and well, that's not a feasible solution. So there has been another solution which has been proposed by Javi Hernandez, one of our colleague. So he says, how about we use the two-phase invalidation mechanism? Like first phase, we do the asynchronous, how it's being done so far. Like caps are dropped, in this case caps, like this is how it works in case of this CephFS. Like once they release that log or release that log from the inode, basically they say that, okay, we are dropping the caps for that. So we could do the asynchronous that way, and once that is done, we can do a final synchronous invalidation for the rest of the clients. So in this case, this is beneficial because by the time the synchronous invalidation occurs, many clients would have already invalidated their cache, and this can reduce the overall latency. But as I mentioned, we are still actively in talk with CephFS team to improve this invalidation callback mechanism itself so that it can be optimal for the libcephfs proxy. And there has been already a Ceph tracker open for this. So any ideas or questions are welcome there. And I think that's all from me. Thank you.